Hi, in this video I will do an example of finding relative extreme value of a function. The function is ln 2x squared plus 3y squared plus 1, and what you should remember that relative extreme value means that we first find relative extreme points, in other words relative max or min points, and then evaluate function at those points. So for that, I need first find critical points. Well, critical points in this case, to find it, we need first partial derivatives. Derivative of f, which is ln of some function with respect to x. It means that we have to find the derivative of that function with respect to x, and then over 2x squared plus 3y squared plus 1 over the function itself. This means that the numerator is going to be 4x over 2x squared plus 3y squared plus 1. And we need to find fy. Very similar computation shows that we will have 3 times 2y over 2x squared plus 3y squared plus 1. And this is 6y over 2x squared plus 3y squared plus 1. And remember, to find critical point, we set these guys equal to 0. First partial derivative is equal to 0. But when you have a fraction equal to 0, and when you have a quotient equal to 0, the numerator needs to be 0. So this implies that 4x is equal to 0. This implies that 6y is equal to 0. And from that, x is 0 and y is 0. So then f has only one critical point, which is 0, 0. Well, okay, that is the first step. Now we have to find the type, or classify the point. Is it max? Is it mean? Is it a saddle point, or whatever? Then we need to use the test here. To be able to use the test, I need to find d, which was fxx at that point, here f0, fyy at that point, and minus fxy at that point, but square of that. Very nice. So let's just go then start finding what is fxx here. Well, let me just write what does fxx mean. It means that we first find the derivative of function with respect to x, partial derivative, and then differentiate again with respect to x. But we already have that first derivative with respect to x. It is here. So we need to find the partial derivative of 4x over 2x squared plus 3y squared plus 1. Okay, very nice. This needs a quotient rule. Derivative of numerator with respect to x, it is 4 times 2x squared plus 3y squared plus 1. Then minus derivative of numerator with respect to x, that is just 2 times 2x. So I had 4x in the numerator, another 4x coming from the denominator, and this needs, and then the denominator squared. Well, I can simplify everything here, but what I need is fxx at 0. So set x 0, y equal to 0. From that, what I will get is that, you see, this term goes away because this is 0, this is 0, this is 0. The only term stays is 4 times 1. That will give me 4. Oops. Yeah, that's good. 4 over, this is 0, this is 0, this is 1 square, which is 1. So the fxx at 0, 0 is 4. Let us do fyy. That means that find partial derivative with respect to y of fy, and that means that we have this guy 4y. Oh, sorry, not 4y. The partial derivative of f with respect to y is 6y over 2x squared plus 3y squared plus 1. Again, the quotient rule we can apply. That will give me 6 times 2x squared plus 3y squared plus 1 minus 6x times the derivative of the denominator with respect to y, which gives me again another. Oh, sorry, the numerator was 6y. Yes, now this is better. 6y. Then the derivative of denominator with respect to y will be again 6y. So this is 2x squared plus 3y squared plus 1 squared. And here's again, I can simplify. We can do all those works, but what we are interested in finding the value of this at x equal to 0, y equals to 0. This goes away, 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 away. And this is 6 times 1 over 1 squared, which is just 6. So we found this piece also. This is 6. Now we need to do fxy. Means that find partial derivative with respect to y of fx. And this gives me 4x over 2x squared plus 3y squared plus 1. Well, again, you can do the quotient rule. Here the numerator has no y in it, so it will be 0 times 2x squared plus 3y squared plus 1 minus 4x times derivative of denominator with respect to y is 6y. And then the denominator squared. Well, again, set x equal to 0. This whole thing is 0 now. This will be 0 and this will be 1. So it will be 0 over 1 squared, which is just 0. So what we did here is we set x equal to 0, y equals to 0. And what we found was that this piece here is just 0. So d for this function, this point, is then equal to d at 0, 0 is equal to 4 times 6 minus 0 squared. And this is 24. Remember the test. D is positive. Then right away you move to the point that what is fxx at that point. D is positive. Fxx at 0 is 4. This is also positive. So D test implies that um, 0, 0 is a relative mean point, not the value for f. Very nice. Now the third step comes in. Third step is evaluate f at the relative mean or extreme point. So what we know is that this is just a definition that relative mean value of f is f at 0, 0. It means that ln of 2 0 squared plus 3 0 squared plus 1, which gives me ln of 1, which is 0. So the f has one relative mean mean value equal to 0. So that's how we find. We have to first find the critical points, use the test, determine, oops, use the test and determine what kind of, so first find the critical point, use the test to classify the point, and then go from there and find the value of the function at that